Hi everyone, welcome back to the channel, and today we are going to be doing an extended video on one of my previous ones for how to calculate chi-squared, except in this one it's going to be a worked example for how you would actually receive it in your geography exam. This could come up in either paper 1 or 2 for any of the units that you do, so it's important that you know how to calculate every step and what writing, so written response, you need to include along with answering the questions mathematically. So the one that I've given you today is in paper 1, coastal systems and landscapes, but it could come up in any of your questions: resources, urban, water and carbon, hazards, ecosystems, global governance. It could come up in any of them. Now, if it's in your optional topics, I do have to say that if it comes up, it won't come up in all the optional topics. So for example, if you've studied coasts this year, that year that it came up, you had to answer chi-squared, but if you studied glaciers, it didn't come up and they had to answer a 6-mark data response question anyway. So it is also a bit of luck of the draw of if you'll have to answer it or not, because they don't always include it in every single unit. If it's water and carbon, everyone will have to answer it, but if it's optional like this coast one, some people didn't. So I thought it would just be a good example. So before we start, please remember to like, comment, suggest anything you'd like for videos. Please subscribe as it helps increase the viewer count. I'm being a bit selfish there. And if you have any questions or queries or want any PowerPoints or documents or advice, just follow my Instagram handle, Jamie_the_geographer. That is my account that I've got. I post when I've put a new video on, and that will be giving you advice, tips, and hints for when I've done that as well. And I believe we will get started with the video. So I'm just going to give you a reminder, what is chi-squared used for? So it's a statistical test that's commonly used for testing a relationship between two categorical variables. When it says that, it means that is there a relationship, is there a link, and it's based on a null hypothesis. The second box says a null hypothesis is basically that there is no relationship between the two variables that you're trying to compare. So in the third box, I've said an example of a null hypothesis would be there is no relationship between plant growth in an area and rainfall in an area. Now, immediately we're thinking, well, of course there's going to be a relationship, but we don't know that. We have to investigate it as geographers, as scientists. But until we have that evidence, we have to go with the null. That's why we do that. And using chi-squared, you want to disprove this and reject the null hypothesis. And again, the overall aim of chi-squared is to measure whether your variables are equally distributed between the groups and to show there is no significant difference or if there is a relationship. So to break that down, if we go back to the third box where it says there is no relationship between plant growth and rainfall, ideally we'd want to have 3 areas of plant growth. We show one with high rainfall, low rainfall, and medium rainfall. If you want to look, will be in the previous video. And we'd want to show there is a significant difference between each of the groups of the areas. Basically, that the high rainfall had a lot of plant growth, area B had medium plant growth, and low rainfall, low plant growth. Or if it didn't make an impact, then the variables were equally distributed, and that's what chi-squared is used for. If you don't understand that still, don't worry. In A-Level Geography, you don't need to understand what it means entirely. You just need to know how to calculate it to get half the marks, and then write a few lines to get the other half of the marks. So a reminder for calculating chi-squared, find the 2 variables that you want to investigate. They'll give you them in the question, but for I've given you an example here, the number of plants in an area and the level of the rainfall. Then you make a hypothesis and a null hypothesis. So your null would be there is no relationship between the 2 variables. Your hypothesis is going to be the opposite of your null. So there is a relationship between the 2 variables. Your null is going to state that the 2 variables are independent. So, you know, the level of plant growth and rainfall, the level of sunshine, and the level of a suntan that somebody has, the idea that there is no relationship. And then you must use your null hypothesis to get an expected result. Now, the expected result is what you'd expect there to be based on your null. So to break that down, if you think there is no relationship, you'd expect everything to be equal. So if you picked a region and there is 144 plants in areas 1, 2, and 3 in total, so the whole area has 144 plants, and you've picked 3 areas, you'd expect 48 plants to be in each area. That is your expected result because the null shows that there is no relationship. Then we calculate the observed result. This is the data that we actually collect when we're out in the field doing field work or in the question that they give you. And then once you have all that, we calculate x squared, and we'll come to that in a minute once we start the worked example, which I've now given you here. So figure 5 shows data relating to coastal flooding in Britain. The investigation is trying to determine whether any stretch of coastline in Britain may be more or less susceptible to coastal flooding. The 96 most severe floods have been analysed. So if we're looking here, reading it before we've even answered the question, we can already see the fact that they're trying to assess if there's any difference between two areas, or if the level of erosion and flooding is equally distant. Basically, is it going to be equal across the UK or is it not? Now, if you've studied coast, I know that's unlikely. You actually know that the Holderness coast is eroding a lot more than some of the Welsh coastlines, so immediately knowing that is not going to be the case, that it's equal. The coastline has been split into 4 broad categories: northwest, northeast, southwest and southeast. And the null hypothesis that they have stated, so already you've got the null, is that there is no significant difference in the location of the floods to affect Great Britain. Then below, or right here on the left-hand side of my screen, is a partially completed chi-squared test. And then below, we've got here 03.2, complete figure 5, and interpret your chi-square result using figure 6. That is worth 6 marks. That is a replacement for your data response. And like I said, you need to know every part of this process because you don't know which bit they're going to get you to fill out. But also, they've given you most of it. So if you can't remember and you're having a bit of a panic, you can kind of work it out. So let's give it a go. First thing, we need to fill in the chi-squared table. So we've got the chi-squared table here. And in the previous video I had, you only need to fill in a few of the boxes. Like I've said, if you look here, you've only got to fill in 3 boxes that are covered in a good, strong black outline. Notice if they've got a dash, that means you won't have to fill them in. They'll normally keep it like this for all of the papers. And normally you can just follow the pattern, like I said. So if we're looking here, O equals 22, E equals 24, O minus E equals minus 2. Well, if you follow the same thing, 16, 24 minus 8, or 16 minus 24 equals minus 8. So even if you didn't know and you hadn't seen this before, you forget, just be careful, be calm, work out the pattern. And like I said again, we need to fill in 3 boxes. 3 boxes, 3 marks. Now let's start with the box in the south row. So the number was 196. Why was that? So if we have a look here, it was O minus E squared. So the value we had was 14 for O minus E, and then we just had to square the value because 196 equals 14 times 14, or for more mathematically inclined, 14 squared. That was all we've had to do there. Just follow the pattern. If you had to work it out from the others, minus 2 times minus 2 would equal 4, minus 8 times minus 8 equals 64, minus 4 times minus 4 was 16. And keep in mind, you will always get a positive figure for O minus E squared because even negative numbers will form a positive number when you times them together. But again, if that's too complicated, don't worry, just follow the pattern. And then we'll complete the box in the northeast column. So this is the bottom one here where my cursor is circling. The number there was 2.67. Why is that, we're wondering? So the answer is 2.66 or 2.67, depends on rounding. You won't lose marks for that really because it's more showing you know your ability. So how do we do that? Well, the value is O minus E squared over E. So our O minus E squared value that we got given was 64, and then we had to divide that by E. So if we went up to the top of it, we got given 24, which was already given to us. We had to do 64 divided by 64 divided by 24, sorry, which gave us 2.67. And remember, you need to fill in your value to correct number of decimal places, like I've said there, but you won't lose too many marks. And when it says the correct number of decimal places, it means, look here, there's 2 decimal places, 2 decimal places, 2 decimal places. So if you're given 2.678152.4, just write the first 2. The examiners don't want to have to see all the numbers. and then check, that's it, like I said, check the figure to see what you're given. And finally, we just need to calculate x squared. So that's just the total value of O minus E squared over E. That is just all of them, which is here at 11.68. So why is that? Well, it's because 0.17 plus 2.66 plus 0.817 plus 0.67 equals 11.68. And that gives us our x squared value. That probably took maybe, if you had a calculator on you, which you would in the exam, that would probably take you about 3-4 minutes, which is about most of the time you need to. If you're worried, that's why. Well, the bits that you get for the final marks, those won't take you very long to write, and we'll show you what you write for the next bit. I just want to keep in mind, please just be aware of this figure 6 that we've got here for your degrees of freedom. That's going to come into play in a second. And once again, you're given this in the question, you just need to know how to use it when you're given the degrees of freedom. So our final value is 11.68, and then comparing this against our degrees of freedom, our value is still both higher than the 0.05 and the 0.01 level. Thankfully, they've only given us the 1 degree of freedom that we need. Normally, they might ask you to calculate it, and they'll give you it in the table, and you've got to determine which one it is. So I'll give you a quick reminder. If you want to calculate degrees of freedom, it's the number of categories you had, so north, west, northeast, southwest, southeast, minus 1, which is why 4 minus 1, because we had 4 categories, equals 3. And that is our degrees of freedom. So keep that in mind, that it's higher than both significance levels. What does that mean? Well, that basically means that there was a 0.01 over 1 probability that our data occurred by chance. That's probably about a 1% chance that our data has occurred by chance, basically. Then finally, we just need to have our x squared value, and we've done that, testing it against significant level. So that would we say to get our full marks. So first of all, you'd say reject the null hypothesis. Why? Because we've just disproven it. This is because our x squared value is above the critical value, and it shows there is a significant difference and that our data is statistically significant. That bit that I've put there in full caps, that's the bit you need to say as well. They want to see that it says statistically significant, because that's what it is all about, to find out if your numbers, if your data to prove this is actually worthwhile. But then a little add-on point, just in case. You must remember that it does not prove there is a relationship between the 2 variables. It just proves that there is a suggestive relationship. So what I mean by that is that just because somebody has gone brown skin due to there being a lot of sunlight, that might not be the only reason for it. That could be due to certain chemicals in their body, certain pigmentation, so different skin colours turn different shades of brown quite quickly or less quickly. While we know that there is a relationship between sun levels and sun tan, there are a lot of different relationships between them. So that's what I'm going to try and say here with Spearman's rank and chi-squared. It just suggests that there is evidence between the 2 variables, but it doesn't prove that there is a relationship. That's what you've got to say. So with that, you've just got to write the conclusion, because it says here, as I've just added again, 0.3.2, the question was complete figure 5 and interpret your chi-square results. So what it means by interpret is, well, you've been given your number, 11.68. What does that number mean? And that's what we're going to add on. So finishing the question. So after completing that chi-square value, we've probably just gained about 2 to 3 marks, got 50% already. The final 3 to 4 marks will come from writing your conclusion and interpreting the chi-squared as the question asked. You've got to also do it within the context of the question. So don't just act like what they're investigating isn't important. You've got to focus on what the question's asking you. If it's about the level of glacial retreat, please refer to the level of glacial retreat, the level of flooding in coasts or water and carbon. Do that, the population density in cities. State the cities. That's what they want. It's not just a general thing. You've got to be specific. With geographers, we like case studies, we like knowledge, we like location. So refers to the top of the question and what the student is investigating. So just a reminder, the investigation is trying to determine whether any stretch of coastline may be more susceptible to flooding. That is what you want to focus on. The investigation is trying to determine what is more susceptible to flooding in terms of a location. And remember, your null hypothesis is also important, because that's what you're going to want to reject, and that's what you're going to want to state with your evidence suggesting so. So finishing the question, This is how you need to respond to gain full marks. Please state any important values, so your x squared value, the differences between two, so the number of coast or flooding, so maybe was your observed value in one area higher than the other? State whether it was above or below the critical value, what does this mean? And if the hypothesis is rejected, state the new hypothesis. So here we go, this is what I've done. Like I said previously, we're at about 2 to 3 marks. Now we've just got to write our conclusion, and here is what my conclusion is. So our calculation shows that x squared is 11.678. Using our degrees of freedom, critical values, our x squared values are both above the value of 7.82 and 11.34, showing that our data is statistically significant at the 0.05 and the 0.01 significant level respectively. That's 1 mark. Therefore, due to our data being statistically significant, we must reject the null hypothesis. That's another mark because you now know that you need to reject it, and shows that some coastlines are more prone to flooding than others. That is your new hypothesis. And then give an example. Due to the southwest having the highest observed value for the number of floods, this suggests that the southwest coastlines is more prone to vulnerable flooding. So now you've applied the data to the question. That's what you need to do to gain the full marks. That would have been another 3 marks. This final line that I've done here, that would be a 4th mark if it was an easy question to fill in and you're thinking, well, hang on, I can't have got 3-4 marks from that. This is the last bit that I said earlier. This test only provides evidence for a relationship between angles and area of the coastline, as only one test is being conducted at one coastline each. This does not confirm a relationship, only suggests evidence. And that is everything. That is all you have to do. So did we get full marks? Well, let's check the mark scheme here. So complete of the chi-square calculation. So 1 mark per correct answer, 3 marks max as shown. So let's have a look. So yeah, we've got all of the numbers right. We've got 196 where my cursor is. We've got 2.67 where my cursor is, and 11.68 where my cursor is. And if rounding is used, that was fine anyway. You can allow it. Interpretation is 3 marks. So the x squared figure of 11.68 exceeds both significance levels. That's 1 mark, like we said. The null hypothesis can be rejected. There is less than 1% probability that these results could occur by chance. Looking at the data, it's clear that there is a statistically significant relationship to affect the southwest compared to other locations, notably the northeast. So look there, we've already done, they even gave you an extra mark for there is a less than 1% probability that these results would occur by chance. So that was the indicative content that they could have given you. My point was valid as well. You also didn't have to attain all 3 marks from that. You could have picked them up from there. So that's where you could have done. It's a range of different abilities. So if you're better at the writing aspect, please don't be worried that you may not have been able to have filled in the whole box, because that may not have always mattered as it's shown with the mark scheme here, because just because the question was out of 6, they gave you more opportunities than it gave you in the question. So just because you only out 3 marks from the box, you could have picked up 4 marks from your writing. So there's more than one way to get it. So according to the mark scheme, we've achieved 4 marks, like we said. We would have gotten at least 3 out of 6 for our calculation. We received the final 3 marks for the following things: knowing our value exceeded the critical value, rejecting the null hypothesis, making an inference about some coastlines that are more prone to flooding, so maybe the southwest, which was more prone to flooding. And we didn't need to put a however point, but it was good to note that, because sometimes calculation might be only worth 2 marks, or that I could have lost a mark due to a rounding error. It's down to interpretation of the examiner, but you don't want to play it risky, play it safe, do everything you can within the time frame. And that's everything. I'd like to remind everybody again, you won't get asked every step in the calculation. Most of it was filled in for us, as you saw, but we don't know what part of it they're going to ask you. They could ask you to fill in the early parts of the question. They could ask you to fill in the very end of the question. And as you've probably noticed, near the end, it gets a lot more difficult. So you need to know how to respond to all of it, even if you're only given 2 or 3 little parts of it. And then if you can do that, it's a gift of 6 marks. But if you don't know how to do it, it's not. And you won't be able to access the top grade if you don't know how to write it and interpret it as well. That's the key thing, interpreting the result. So if you can be able to do all of those, then you will be fine. And then finally, just another quick reminder, please like, comment and subscribe, and then follow my Instagram handle, Jamie_the_geographer. And that will allow you to gain access to more PowerPoints, videos, suggestions on what you think might be best for helping you with your A-levels next year, as I know it's going to be very stressful, as we don't know what content you're going to be required to cover and the level of which, so any advice would be useful, I feel. So I hope that was very helpful to everyone, and I will see you all for our next video. Bye for now.